Hi everyone. So thanks for taking your time to watch the recording video. Okay, because or else we are not able to finish off the syllabus before your test. Okay, so we are just going to go through some of the parts that we are not able to cover on Thursday class, but I think it wouldn't be like reaching 2 hours now. So just make sure that you understand everything. That if let's say there's any question, we can always discuss it also when you come back next week. Okay, so question 6. This is the question that we have done it previously by using Ti-Nspire, which using the generate function. So we are going to go through the other method, which we do a bit of manual calculation to get to the answer. And after that, we will explore the other function in your calculator as well. Okay, so this is method 2. Okay, I'm just going to use the other color of pen so you can, differentiate like these are something that we already did it on Thursday. Then after that, the purple color means the new thing lah. Okay, so from the question itself, we already get the nth term rule, which is equal to 2 multiply 1 over 4 and power n minus 1. Okay, so when the question asks which term is equal to this, then which means that we are finding what is the n that gives us the term 1 over 32,768, right? So we can try to put them together as an equation. So I have 2 multiply 1 over 4 power n minus 1 equal to 1 over 32,768. Okay, so how are we going to solve this manually without using your Ti-Nspire first? Okay, so if I want to solve the unknown n here, then we know that the first thing that we need to do is bring 2 over, right? So their relationship here is multiply. So when you move this over, then it will become divide. So the left-hand side still remain. I only bring 2 over, then it become divide 2. So you can straight away press this in your scientific calculator and you divide by 2. And you should be able to get 1 over 65,536. Okay, so in indices, I believe in your secondary school, you learned this before, which for the law of equality, we need to have our base the same, then only I can say that the power is the same. This is what we learned in law of indices, right? Okay, which means what do I need to do here is that I need to make sure that I can find it in my calculator that 1 over 4 power something is going to give me 1 over 65,536. There's no shortcut to do it, which means that you will just be trying out in your calculator until you can get this value. For example, 1 over 4. Okay, so maybe I will just try out 6. Then I realize it's not big enough for the bottom one, for the denominator. So I try to increase it. So I still didn't get it. Then I try to slowly increase until I can get to that number. So you should be able to get power 8. So that's why power 8. So now we already achieved what we want here, which the base of my indices is the same now. Then I can continue. N minus 1 equals to 8. So from there, then I can get n equals to 9. So you can see you get the exact same answer as the top that tell you that T9 is equal to 1 over 32,768. Okay, cool. I hope that you can follow along. Okay, so now we move on for method 3. Okay, method 3 is basically using method 2 as well, but it's just that instead of solving the equation by ourselves, we use Ti-Nspire to solve it. So which means that my first 2 steps is going to be exactly the same. So I'm just going to copy. Okay, 2, 1 over 4 n power 1. Okay, and we know that we are going to get Tn equal to 32,000 plus. Okay, so now, same thing. I try to construct an equation based on that. So, but instead of solving this manually, I'm just going to use my Ti-Nspire to do it. Okay, so I hope that you still remember a function in your calculator, which is called as nsolve. Okay, so no worries, we'll try to go through that again. So you will add calculator. So there is one function in your calculator that for you to solve an equation with one variable, then we can try to put nsolve. it doesn't has to be like linear. So anything that you are doing for one variable. So remember the n here is a default function. So you are not going to change it to, for example, k solve or p solve or x solve. Okay, so it's always n. I think the n stand for number for them. So n solve, then you open a bracket, then now you type in the equation that you have just now. Okay, which is this one. Okay, I'm just going to show it like that. Okay, so I will press 3. Okay, so remember sorry, not 3, 2. Okay, you need to make sure that you put multiply, or else the calculator wouldn't be able to know what is the relationship between these two. Okay, and then you open bracket, because for the power n minus 1, it only belongs to 1/4, not including 2. So that's why open your bracket. There are two ways for you to press your fraction. Either you can do 1 divided by 4, meaning 1/4, or if you don't like it like in one row like that, then what you can try to do is you can see this icon here. So this button here beside a book icon. So when you press that, then you should be able to get a list of different notation that you can use in math. So we are going to use this, the fraction one. Then I can put 1, tab, and then 4. Okay, so either one, you do 1/4 also no problem. Then after that, you close your bracket. Okay, and then you still remember how to do your, the power, right? So you press this, okay, then you get up, then now you key in n minus 1. Okay, so we complete like the left-hand side part of the equation already. Okay, now then we continue. So make sure you go down, okay, which means you go to right. So make sure your equal sign is not up there. Okay, so equal to, and then you key in. So same thing is a fraction. So either you want to use this, or like, for example, I just do slash here. Okay, it doesn't matter. Okay, now then you need to tell the calculator what is the unknown that you want to solve. So we put comma, then this is the time that you put in your unknown. So which means if let's say you are solving for p, then you write p. In this case, we are solving for n, so we write n. Okay, so again, you are not changing the number, you are not changing your unknown here, you are changing your unknown here. Okay, then you press enter. So you should be able to get 9. If let's say you cannot get this answer, make sure that you check properly until you write everything properly. Like, is there multiply here? Is all your bracket put properly? Is all your numbers correct? Those things. Okay, so you should be able to get 9, because 9 is our answer since method 1, right? So that's why we can just write down n equals to 9. Okay, so any part that you can use your calculator, then you can just do this in your calculator. So that's why we can get T9 equal to 1/32,768. Okay, I hope that clarified. So you can just try to, check that out. And during your exams, if let's say you were to ask me which one is prefer, I would say that under the case that you have your Ti-Nspire with you, then we rarely solve, we rarely solve manually. But if let's say you forgot how to generate sequence and you forgot how to, end solve, then you will just do it manually lah. Okay, but normally you will forget like how to generate your sequence, but you can know different methods so you can check your answer during your exams. Okay, so that's question 6. So which means now for question 7, we are going to do similar thing as well. Okay, because for this one, right, we are not able to do it manually. Why is that so? Because let's try it out. So this is method 2. Just going to put it at the right hand side. Okay, so same thing, right? But now this is not equal. So the question asks, which is the term? Is the first one exceed? So that's why more than 1 million. Okay, so when we are doing this, then which means that same thing, my Tn here is denoted as 5 multiply 2 n minus 1, right? Then greater than 1 million. Okay, so the thing is this, you can imagine that you go and, okay, let's try this out. Okay, you can imagine that follow the same way just now. I will be taking 1 million. Okay, and then divide by 5, right? Then I get 200,000. Okay, so once I get that, then I need to imagine, will I be able to get 200,000 exactly when I having 2 as my base? Okay, so which means like 2 power, let's try 2 power 9. Okay, this is too small, maybe 20. Okay, so you can see that I am getting 20 is 1, 2, 3. Okay, this is too much already. Okay, anyway, you try it out and you realize that you wouldn't be able to get like exact value or me, okay, unless you are just trying to find out what is the whole number that get higher than that. Okay, so what can we do here is we only use our Ti-Nspire. So which means same thing, still in the page of calculator. Okay, so and solve. So now become 5 multiply 2 power n minus 1. Okay, and we cannot put greater than, so you are just putting equal sign. So 1, 0, 0, 0, 0, 0, 0. Okay, then we are solving for n also. Okay, make sure you type everything correctly. Okay, then after that you press enter. Okay, so in this case, you must make sure the n minus 1 is here, so you don't put like bracket here, you get what I mean? Okay, because the n minus 1 only belong to 2. Okay, so now you get 18.61. So we can write down n must be greater than 18.61, then only you are able to get a term which is greater than 1 million. So that's why it's, aligned to our answer just now. So, but then because when we're talking about term, right, it's like first term, second term, third term, and so on, right? So you won't be getting like 18.61 term. So that's why the first whole number that more than 18.61 is n equals to 19. Okay, so after you get 19, then only you try to substitute back into the equation. So 5 to 19 minus 1, because you imagine if you are using this method, then you are not getting this value first, right? So that's why you can just do your calculation in your calculator. So 5 multiply 2 to the power of 19 minus 1 is 80. Then you should be able to get the exact same number here. Okay, then we just write down our answer. Okay, so that's method 2. So during exams, either one you can use. So depends on which one you prefer lah. Okay, so for question 8, okay, this is going to be very similar to what we have for method 2 as well. The only thing is about the sign here. Okay, so same thing, method 2. Okay, so I am getting the term which becomes lower than 10. Okay, so when we are doing this, then which means that we are going to have A, R, N minus 1 less than 10. Okay, same thing. So our n might be, might not be a whole number that we cannot use the law of equality of indices to solve it. Okay, of course, if you learn additional mathematics before or you learn logarithm before, then you know how to solve this kind of equation, but not everyone do that, and it's not it's not a compulsory thing to know for your max application. So that's why I won't be spending too much of the time talking about that. But there's one thing that you need to be mindful for this question is that, let's try it out. Okay, same thing, we are going to use and solve first. Okay, so key in this in your calculator. So and solve. Okay, open your bracket. 5,000 multiply. So remember, it's a fraction. So you need to put a bracket, or else then the power will only belong to 4. Okay, then after that, power, and then n minus 1. Okay, so equal to 10, then comma n. Okay, so you get 5.48. So you see, right, we are having a problem here that you realize if let's say you continue the same idea as the previous one, because this is more than, so I retain it as more than. Okay, when I try to do this, if let's say I retain the sign here, then it will be n is smaller than the number that I get, which is 5.48. Okay, then for this number, you can go and check in your calculator, right? For the whole number that is the first lesser than 5.48 is 5. So if you are going to substitute 5, are you really able to get the number smaller than 10? You realize that you didn't, this number is still greater than 10. So why is that so? It's actually because of, in this case, you are going to flip your sign. Okay, if you remember for inequality, right, you need to flip your sign when you divide by a negative number. So supposingly, we are doing all this question by using logarithm. So the idea is this, you can try this out. Okay, when I try to log 2, I'm getting a positive number. So which means later when I bring log 2 to the other side, like when I divide it, then I still divide by a positive number. So I no need to change my sign. But in this case, why I need to flip my sign is because of if I go and log 1/4, then what happened later is that it will become a negative number, which means I will be having a step which I need to divide by negative number if I am doing everything manually properly. So that's why when I divide by a negative number, then I need to flip my sign. Okay, so you are not really need to understand the idea behind it. The only thing is you need to make sure that any number which your ratio, right? Sorry for that. Any number for your ratio here, if let's say it's a number that lesser than 1, okay, then you need to flip the sign. Okay, so as simple as that. So that's why if you were to ask me, I will say that the first method is still much more useful and much more safer to use. And especially when we are talking about finance, then we will use first method most of the time also. Okay, but knowing second method can help you checking your answer in a bit. And maybe for those who like to solve equation, then you will prefer this way. Okay, so n is greater than 5.48. So that's why you can get n equals to 6, which is exactly the same answer as we have just now. Okay, so that's why substitute. So 5,000, 1/4, 6 minus 1. Okay, so from that, then you can just key in that in your calculator. So 5,000, sorry, 5,000, 1/4, and then power 6 minus 1, which is 5. So from there, you can get 4.88. Okay, all right, so that's the question here. So same thing, we are just going to finish off the application part, which means like for question 4 and 5, you can also use the second method. Okay, so I'm just going to talk about that first when we come back to question 9. Okay, so for this part, okay, so in which year did she sell over 2,000 items? So the same thing. So this is the other alternative. Okay, so I can actually write down here. Okay, so or the other way to do this is, first sell over 2,000, then which mean 50, 1.2, and minus 1 over 2,000. Okay, so same thing, then you can use the NSOLVE function in your calculator. So that's why 50 and solve. Okay, 50 multiply 1.2 power and minus 1. Okay, then equal to 2,000 and then comma n. Okay, so you can get the number. So in this case, you can see 1.2 is more than 1. So that's why you no need to flip the sign. So that's why 21.23. So n greater than 21.23. Okay, so that's why we can get n equals to 22 as well. Okay, n equal to 22. Okay, so of course it will be depends on like this question. The question didn't say what number that you need, then you can leave your answer like that. But I mean, basically, if let's say you are using this method, I will highly encourage you to, just find out what is your T22. So to check that is that number really like more than 2,000 already. Okay, so you can just try to, do that in your calculator. Then you should be able to get 2300.26. So that's why it gives us the same answer, which is in the 22nd year. So how do you defining this is exactly the same like how you do this part also. Okay, so like the end, you need to go back to the question, like what is the question asking? So like in which year? So that's why your answer is in the 22nd year. Okay, question 5. So similarly, okay, same thing like just now. So after how many years, the cost of the car costs below 100,000. Okay, so same thing, equation. 225,000 multiply 0.95 power n minus 1 lesser than 100,000. Okay, so same thing. So you can type this in your Ti-Nspire. Okay, so and solve 225,000. Okay, then multiply by the value just now 0.95. Okay, and then n minus 1 equal to 100,000. Okay, comma n. Okay, then you should be able to get 16.806. So sorry, 16.81. Okay, so in this case, you can see same thing. 0.95 is a value that is lesser than 1. That's why you need to flip your n. Okay, so flip your n, then writing down your answer just now. So 16.81. Okay, so now let me try to explain further up. Then when you flip the sign, then only this makes sense. You know why? Because you see, you are finding at which year the car fall below 100,000 mark. So it cannot be lesser. Like it's supposed to be, the 7 year, 18 year, 19 year, 20 year, 21 year, as older the car, then the car will cost, even lesser than 100,000. What? If let's say your final answer is like lesser than, right? Then it's like very weird. Even 1 is also lesser, but 1 is actually not costing lower than 100,000. Okay, like 5 also, 6 also. So it cannot be like the newer the car, then the car costs lesser, right? So that's why, there's some idea behind it that you can try to think about. Okay, so n is greater than 16.81. So you can, deciding whether you need to flip your sign or not by looking at this number, because when you log this number, you are getting a negative value. Okay, so that's why n equals to 17. Okay, so the same thing, the 17 here, meaning in this case, because we are putting our 225,000 at as T1, and that's the value at the first year. So which means when you are getting 70, it only tells us that this is at the 17 year. Okay, but the question actually asks after how many years, right? So after how many years? So which means in this case, at the 17 year, it means that after 16 years. Okay, then if you are using this method, then you need to manually write down. So T17, T17 is your term that you want. Okay, but it's just that after 16 years. So equal to, then we substitute 17 into the equation. Okay, then from that, you should be able to get the value. Okay, so 225,000, 0.95 power 17 minus 1. Okay, then from there, you can get 99028.50. Which is exactly the same like what you have previously by using generating the sequence. Okay, so that's this part that I want to explain. Okay, now then we need to go back to the question 9 just now. Okay, at a page of 117. Okay, find the 20th term of a geometric sequence in which the third term is 2 and the 10th term is 4,374. Okay, so we can try to write down first whatever that we have. Okay, so the question give T3 equal to 2. Then the question also give T10 equal to 4,374. Okay, so now what we can do is, same thing, I'm going to introduce two methods as well. So the first one, just using a bit like common sense, okay? So you can imagine if let's say now this is T3, then I have T10 here, right? So how many R do I actually multiplying so I can get to T10? Okay, so you can imagine T3 to T4 is 1, then to T5 is 2, T6 is 3, T7 is 4, T8 is 5, T9 is 6, and to T10 is 7. So that's why you know that T10 is equal to T3 multiplied by R 7 times. Okay, so you multiply R itself, right? So every time you multiply R, multiply R, multiply R. So that's why it's not 7R. You're not using R to multiply 7. It's like you multiply R itself by 7 times. Okay, so that's why we know that how do we get this number? It's actually from 2 multiply R power 7. Okay, so we can move the 2 to the other side as well. So I have R7 equal to 4374 divided by 2. Okay, so just use your calculation. And from there, you should be able to get R power 7 equals to 2187. Okay, so this is a root. So that's why in your calculator, okay, so you can press shift, then you press this. So you should be able to see this sign. Can you see that? Okay, the one in yellow color. So shift and you press on this button, then you press 7 and then 2187. Okay, so when anything to the power of 7, when you want to move over, then you do root lah. I mean, of course, if you want to just try and error, like what is the base that give you, what is the base power 7 and give you that number, there's nothing wrong as well. Okay, but that one you need to, keep on trying. Okay, so in this case, then we can get R equals to 3. Okay, so the question asks for the 20th term. As we getting the R, then we also need A. So you can try to imagine the same idea here. So if let's say today, to get the next term, my common ratio is to multiply 3. If I want to get the previous term, to get my next term, right, I will always need to multiply 3 to the previous term. But for me to get my previous term, then which means I can divide by 3. So if let's say I have T3 now, then which means to get my T1, what I can do here is I just take my T3 to divide by 2 times of R. Or you can try to imagine it's the same thing like this. Sorry for that. Okay, if you want to find your T3, right, isn't it you will use your T1 to multiply R squared? So that's why now you want to find your T1, then you divide. So T1 equals to T3 divided by R squared. So our T3 here is 2. Our R that we find out is 3. So that's why we can get 2 over 9. Okay, so T1 is basically our A. Yeah? Okay, so A is T1. Okay, so from there we get our A and R already, then we are able to proceed with T20. So T20 equal to A, R, and minus 1. Okay, so as simple as that. Okay, then you can key in that in your calculator, then you should be able to get 258,280,326. Okay, so that's method 1. Okay, so for method 2 wise, it's more on like using formula. Okay, we do the same thing for arithmetic as well. So that's why, okay, let's do this. Method 2. Okay, I'm writing down the 2 term as well. So the third term is 2. So third term is 2. Okay, then my second one is the 10th term. Okay, is 4374. So what I can try to do here is that by using the formula, I know AR power n minus 1 equals to my nth term, right? So for T3, now I don't have my A, I don't have my R, so I leave it as a variable. So leave it as an unknown. So A multiply R power what? So I know I'm finding T3, right? So that's why 3 minus 1. So AR n minus 1 equal to 2. So from there, I get my equation, AR power 2 give me 2. And that's the first equation. Okay, then we do the same thing for the second one as well, AR n minus 1. So AR 10 minus 1 equal to 4374. So I got my second equation, AR power 9 equal to 4374. And that's basically my second. Okay. So now simultaneous equation, so you can do division because you don't have anything that you can minus like or anything that with different power, even their base is the same, you also cannot do minus. So that's why we take the larger one to divide the smaller one. So we have AR power 9 divided by AR power 2 equal to 4374 divided by 2. Okay, then from that, then we can proceed. So A and A, they eliminate each other. So for indices, then we know that, okay, I write down the, okay, for indices, we know that for any number divide by a number with the same base, then you are just going to minus off the power, right? So which means it's the same case here. So what I have here is R9 divided by R2, then which means that it's R power 9 minus 2. Okay, equal to, then this one we can just type it in our calculator, 2187. Then you can get R7 equal to 2187, which is exactly the same with what we have just now. Okay, so you can get R equals to 3. So now we can do some substitution. So substitute back into equation 1. So AR square equals to 2. Then from there, I get A equals to 2 over 9. Okay, then for the rest of the part, they are exactly the same with the previous one already. So that's why T20 equal to AR and minus 1, which give me exact same value as just now in method 1. Okay, yeah, so these are the parts that we need to top up for the question that we didn't able to finish it. Okay, and now we are going into the last part for geometric sequence, which we talk about how is the graph display going to be like if let's say we try to plot the sequence on a Cartesian plane. Okay, so let's look at page 118. Okay, I hope that you still remember that for arithmetic sequence, if let's say we generate the sequence and we try to plot it on the Cartesian plane, right, we are getting a linear graph, which all the points will lies on a straight line. All right, so if let's say for a graph for geometric sequence, it will give us points that lies on a curve. Okay, and to be exact, this is called as an exponential graph. Okay, so how is the shape going to be like? So we are going to use these two examples to, roughly go through how is the shape is like by using our Ti-Nspire. Okay, so I will just randomly, so which means you can put any number, but then you will still be getting the same graph. I mean, the same shape of the graph. Okay, so I will just, you can try to put this as T1 equals to 2, for example. Then this one you can try, let's say maybe T1 equals to 100. Okay. But I repeat one more time, it doesn't matter what is the number that you are putting, but we are just trying out. Okay. So what I want you to do is you take out your Ti-Nspire. Okay. Then you can open another new page. Then you go to list and spreadsheet. Okay. Now I want you to do this for your first column first. So it's the same thing like when we are doing arithmetic. So we don't need so many points. So maybe we are just going to do like 6 points. Okay, then that one is sufficient already. Then I will name this as N. Okay, sorry, small letter N. Okay, then now we are going to generate the first sequence that we have here, which is multiply by 3. Okay, so menu, data, generate sequence. Okay, so 3 multiply UN minus 1. If I want to get the current term, I get 3 to multiply the previous term. Okay, initial term, let's put 2. I only need 6 number. So that's why I changed the N max to 6. Then I press OK. Okay, then you should be able to get your graph, right? Okay, now let's generate the other one first, then we plot the graph together. Okay, so the second one is this one. Okay, 0.5 multiply Tn minus 1. So same thing, menu, data, generate sequence, 0.5 multiply un minus 1. Okay, so initial term is 100. So same thing, let's generate only 6 terms. Okay, then you press OK. Okay, so now we have already gotten our sequence here. Then we can write down, this is the first one that we are going to look at. I'm just going to put it AN, then this one BN. Okay, so to make it easier, you can just follow my naming. It doesn't matter, but you just need to remember this one is the first one, this one is the second one. Okay, so if you still remember how to do your scatter plot, then control, then open another new page, right? Data and statistic. So when you are plotting your sequence on a Cartesian plane, your x-axis is always the n, which means the 1, 2, 3, 4, 5, 6 that you substitute. Okay, then after that, here will always be your Tn. We look at the first one first. Okay, so you can see that this is the graph for the An. Okay, so be noted that actually this 2 doesn't lies on 0. So you can see this is actually x equals to 1, y equals to 2. So this one, x equals to 2, then y equals to 6. So why you can see is very near to 0 is because of like this value is too far away already. So that's why they has to be like very near to the 0 here. Okay, so let's try to just draw a draft one here. Okay, so my n and my Tn. So you need to show the curve. So for example, maybe I will just plot a graph 1, 2, 3, 4, 5, and 6. Okay, so remember we don't need a graph. We only need points that show us the shape. So which mean like this. Okay, then you can imagine like you are drawing a curve. Okay, then even higher up. Okay, so you should be able to get like a shape like this. Is that okay? So I hope that you are following well. Maybe for this one, I draw a bit lower. Okay, so it's like getting higher and higher like that. Okay, so now we draw the second one. Okay, so the same thing. Now I'm going to change my AN to my second sequence, which is PN. Okay, so you can see the graph like going the other way around from 100, then after that it decreases to 50, 25, 12.5, 6.25 and continue, right? So same thing, we try to plot it here. So n equals to 1, n equals to 2, 3, 4, 5, 6. Okay, so we might be having a highest point here and decrease, 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 decrease. Okay, so same thing, you might want to make sure that you are getting like a curve going down. Okay, all right. So maybe I think my first one here is not so clear. So you must make sure that, you are doing a curve like that. Okay, so now how are we going to explain the changes here? So for arithmetic sequence, because it's a straight line one, so that's why I know that the term is going to increases or decreases with a specific amount of gradient, because for straight line, the gradient is always the same. But in this case, you will realize that, for example, for the first one, right? If your R is greater than 1, what can you realize is that your term value is going to increases, because when you multiply by a value which is greater than 1, then you can see the number will keep on increases. Okay, but how is it increases? It's not constant, right? For example, if you go back to your sequence, you can see that the difference between 2 and 6 is actually a 4, right? So 6 to 18 is 12. Then 18 to 36 is, 18 to 54 is 36. Then after that, it's even getting larger over here. So that's why this is called as increases with increasing rate, which means that you are increases, but then the difference of your increment, right, is getting bigger and bigger. Okay, I give you another example, maybe you can understand better. Like we can have a situation that going to be like increases with decreasing rate. What does that mean? For example, if I have 100, 200, 270, then after that 320, and then let's say 350. Okay, you can see this sequence increases. Am I right? Nothing wrong about increases. But the thing is, from here to here, you increase 100. From here to here, you increase 70. From here to here, you increase 50. Here to here, you increase only 30. So you can see the term getting bigger and bigger, but the difference between the term is lesser and lesser. So this is increases with decreasing rate, okay? So just now this one, you can see it increases and the difference of the number become bigger and bigger, right? So that's why this is called as increases with increasing rate, okay? Now I want you to try to think of this. So, all right, sorry, let me finish this first. I thought I want to mention this already. Okay, so for this term, if you keep on generating with the sequence, right? Okay, you don't need to change that in your calculator, but you can just look at my screen here. Okay, for example, instead of generating 6 number, I'm generating 100 number. So you can see that if I continue with this sequence, right, the number would just get larger and larger as I move on. Am I right? Okay, so you like get, like 3, then you need to multiply 10 to the power of 15 like that. Okay, so the number will keep on increases if you keep on multiplying 3. So there wouldn't be an end of the number that you are getting. So which means that it will just increase infinitely. So which means until infinity. Okay. So that's the idea for the first type of the graph, which means it's a positive value and this value is greater than 1. Okay, so like when you multiply 1.1, 1.2, you will always get this kind of shape. Okay, whereas for the second one now, after you're learning just now, this is called increases with increasing rate, right? I want you to try to think about first then, how is this graph to be described? Okay, so same thing, you can either look at this graph, okay, or you can try to look at your sequence. So you can see that in this case, from 100 to 50 is a difference of 50. 50 to 25 is a difference of 25, then 16.5, then 6.25. Am I right? The difference between the number that you have. Okay. And also, if you try to look at the graph, right, you can see the first one, the difference is so much. Then the difference getting smaller, getting smaller, getting smaller, and getting even smaller. Okay. So that's why this is called as the term value decreases, because definitely you can see going down. So decreases, and the difference between the number getting lesser and lesser. So that's why it's called as decreases with decreasing rate. Okay, so at the same times, you will be having decreases with increasing rate as well. So how is that going to be like? Let me try to give you a sample here. You don't need to write down here. I mean, it's just for your understanding, like what is that meant by, increases with increasing or decreasing rate, or decreases with increasing or decreasing rate. Okay, for example, if let's say today I have 1,000, okay, then after that 900, then become 700, then after that become 400, then after that become 3. Okay, let's say become 0. Okay, so you can see from here to here, you decrease 100, right? From here to here, you decrease 200. From here to here, you decrease 300. From here to here, you decrease 400. So this is called as decreases with increasing rate, because you can see the number getting smaller, so that's why decreases. But the difference of your number getting bigger and bigger, so that's why increasing rate. Okay, so I hope that you get the idea of that. Okay, for this type of sequence, right? I mean, not this one, because this is definitely like more like the arithmetic kind of thing. Okay, so let me try to erase this. You don't need to write that down, but you only need to understand what is that meant by, increasing rate or decreasing rate, or just put the notes beside for you. Okay, so not to confuse you, I delete that first. Okay, so now, if you're trying to look at this, same thing, you don't need to do that in your calculator, but if I generate it to 100, okay, you can imagine that as you keep on multiplying 0.5, okay, the number will get smaller and smaller, smaller and smaller. But you can imagine that as you keep on multiplying with a positive number, because how do you get the next sum? You multiply 0.5, right? As you keep on multiplying with a positive number, you wouldn't be having negative in your answer unless your first term is negative. You get what I mean? Then your first term is negative, then when you multiply, you get negative, then you continue to get negative again now. So if let's say your first term is a positive value, right? If you keep on multiplying with a positive number, you will only get a number like becoming very, very small, but then you will never get a negative. Okay, I hope it makes sense. So this graph will just continue to be like approaches the 0 like that. Okay, but it will never go to negative. Okay, so the turn of the sequence lies on a straight line that decreases and approaches 0. So it will just be like very, very small, that getting nearer and nearer to 0, but it will never get to negative. So note that this term will never be negative. Okay, so this is the first type of the graph that we are looking at. So basically, we are looking at positive ratio. Either the ratio is a number greater than 1, or either the ratio is between 0 and 1. So these two are more common in terms of application, because normally you get like positive ratio lah. Okay, so that's the first part. Okay, now for the second one, we are going to look at the negative part. For this one, it's not so much in application, but you need to know it theoretically. I will explain it why further, like you will never have this kind of graph in application. Okay, so same thing, we try to generate the graph also. Okay, let us do this one, still do T1 equals to 2. This one, we still do T1 equals to 100. But in terms of 6 term, let's generate maybe 8 term. So you will be able to see the graph better. Okay, so I'm going to increase this until 7 and 8. Okay, then we go and generate the sequence first. Okay, so for the first one, so same thing, menu, data, generate sequence. So multiply -2. So that's why -2 multiply UN minus 1. Okay, initial term is 2. All right, then after that, oops, sorry, initial term is 2. Then after that, I only need to generate 8 terms. So that's why I change this to 8. Then you press OK. Okay, then this is supposed to be what you get in your calculator. Then we do the same thing as well for the second one. Then we do everything in one shot, so it's faster. So data generate sequence as well. Negative 0.5 multiply UN minus 1 also. Okay, initial term 100. So I'm going to change it to 8 term also. Okay, then press OK. So I'm going to name this as CN. I am going to name this as TN. Okay, so the third one, the fourth one. Okay, now go back to the page of your graph. So I hope you know how to switch between already. Control going to the right. Okay, so let's change this to N. Okay, then after that, now I'm going to draw the CN graph. Sorry. Yeah. Okay, so the graph for CN. Okay, so you should be able to get the shape like this. So you can see that the graph go from 2, -4, 8, -16. So you can see the difference between number getting bigger and bigger. This one, the difference is 16. Then this one, the difference become 32. What I mean is like from the y equals to 0 axis. Sorry, from your x-axis, which is your line y equals to 0. Okay, so the difference here is 32. Then the difference here becomes 64. Then here become 128. Then here become 256. Then why is it positive, negative, positive, negative? Because your ratio is a negative number. So when you start with a positive number, when you multiply a negative number, you get negative, right? Then negative might multiply negative, you get positive again. Then positive multiply negative, then you get negative again. Okay. So our graph will look like this. So let's try to draw it. So we will be drawing 6 only because that's not enough space, but I'm just doing 8 so that you are able to see them clearly. Sorry for that. Okay, let me do that better. Okay, so the first one is a positive number first, right? Because our T1 is 2. So it's here. Okay, then the next one become -4 already. You are going down, but the distance is slightly further than what you have with 1 here. Okay, the difference here getting bigger. Then difference here getting bigger as well. Then difference here getting bigger as well. Okay, and getting even bigger, then getting even bigger. Okay, so you will be able to get a curve shape as well. So you see, it's like a curve here. It's also like a curve here. Okay, you don't need to do the graph. All right, so yeah, what I mean, like you're still getting a curve, it's like that. Okay, so if you try to, compare to what you have at the top there, right, you can imagine that what happened here is that your 1, 3, 5 stay, then after that your 2, 4, 6 go to negative. So you can still see like a similar shape there. But because of your ratio become negative number, so like some of the, alternatingly, you'll be having positive, negative like that. Okay, so that's the first one. Okay, then the same thing, we go to the second one also. So I'm going to change my CN to DN. Okay, so you can see the graph the other way around. So from a bigger one, because you are multiplying with 0.5, so your number magnitude getting smaller and smaller. You can see the difference here is 100, then difference here become 50, the difference here become 25, 12.5, 6.25, 3.125 like that. Okay, so same thing, we are going to plot 6. So 1, 2, 3, 4, 5, 6. Okay, so that's why you can start from 100. Okay, then it become like -50, then 25. Okay, 12.5. Okay, then even nearer and then nearer. Okay, so same thing. You can see like it's exactly the same thing like that, but alternatingly, some of the point will go, alternating, you are having the points go to negative side. Okay, so that's the graph that we'll be getting. So you can see that when your ratio is a negative value, the term value always alternate in sign. Okay, and this explains why you rarely have application that actually look like this. Because for example, right, it wouldn't be like this month the number of people is 2, then next month become -4, then next month become 8, then next month become -16. You get what I mean? Yeah, because in application then normally you still be using it to measure number, then estimate numbers like that. Then it wouldn't be like any cases that you'll be having negative. Okay, unless you are having like really special case lah. Okay, so if let's say your R is a value that lesser than -1, for example, -2, then the magnitude increases. Okay, magnitude, which means I don't look at the sign, but I only look at the pure difference between the number, with the x-axis that I have. It's getting bigger and bigger. Then for this one, the difference getting smaller and smaller. So that's why it decreases. Okay, so as stated in the objective, so that's why you will need to know how to plot the graph. Then after that, what is the rough shape that you'll be getting for both arithmetic and also geometric. So it will help you a lot, like when you are doing question and those things. Okay, so that's the part for here. Okay, and before we end here, I'm just going to discuss for the last one in case like anyone still don't understand. And also I want to specifically talk about something that I missed out, which is how to use the calculator if let's say we are using T0 R power n. So I will try to talk about that in the next part. So for question 7, if let's say you think you already get the idea quite all right, then you can skip the part for ABC. But I will still encourage you to watch the D part because that's the thing that I forgot to mention in the class. Okay, so we try to go through them together. Okay, so a block of land is valued at 250,000 at the year of 2000. So the value will increases at 4.5% per annum. So Ln represent the value of the land after n years. So the key thing is you need to understand that the n here stands for after n years. Okay, so that's why when we try to deduce a rule, then you can try to ask yourself, because the meaning here is n. So which means when you write L1, it means the value after 1 year. So you know that this is not your value after 1 year, right? Is your value of land when you basically start buying it, right? So this is after 0 year. Okay, I hope you get what I mean. Because this is your initial value. This is not your value of land after 1 year. This is not even 1 year yet. This is your starting value. So that's why if follow this definition, then which means that my 250,000 is L0. Okay, then after that, your common ratio is 1.045. Okay, if you are using L0, then which means that your equation will look like Ln equal to, so you remember Tn equals to T0 multiply R, multiply R to the power of n. So remember, if you are using T0, then your power will be only n. Okay, but if let's say today you don't prefer this, if you want to do another one, it's the same thing as well. So in that case, if you want to use a Rn minus 1, you must always make sure that your A is T1. So that's why if you want to do that, then which means we need to find out what is our T1. And how can you do that? Because the starting is 250,000 watt. If I want to find the value after 1 year, because L1 is after 1 year. So that's why I will try to substitute. Okay, I will try to multiply with 1.045 to get the value after 1 year. Okay, then from there, you are able to get $261,250. So which means in this case, right, it's all right as well if you write it as Ln equal to A R, because you are using A. So that's why your power must be having n minus 1. Okay, now we continue for part B. Okay, so you can try to imagine that the idea is every time your ln, the n must represent something. Like for example, if I tell you n, then I didn't tell you what is my n, then it's like quite irrelevant. Like normally for the question, they need to denote that properly, that what is your n. Okay, so in this case, right, you can see that your NLN here is defined as the value of the length after n year, which means no matter what we have, right, we are going to fit into this situation to solve the question. So for example, when we look at part B, determine the value of the length at the 5th year. So this question, the ln doesn't stand for the value of the length at the n year though, it stands for after n year. So I need to think about, if let's say today I want to find the value of the length at the 5th year, is it equivalent to the value of the length after how many years, right? So that's why at the 5th year, meaning that you already go through like 4 complete years. So that's why the value of the length at the 5th year is basically the same as the value of the length after 4 years. So that's why in this case, we are putting it as T4. So no matter you substitute into the first equation, which is 1.045 to the power of 4, if you are following the first one. If you are following the second one, then which means you will be doing 261250 multiply 1.045 to the power of 4 minus 1. So which means L4, so your n is 4, right? So that's why here 4 minus 1. Okay, then when we continue, then you will realize that no matter which one you are keying in your calculator, right? At the end of the day, you should get exact same answer, which is 298,129.65. And you realize that this answer is exactly the same with what you have previously, because you realize that the question is actually asking the same thing. But here you are using L5. Why? Because the definition for your n, the meaning of your n here is different. But then at the end of the day, I'm still getting same thing. Because at the 5 year and after 4 year, isn't it? I should get the same value. Am I right? So that's the idea. Okay, but then your working might be a bit different, depends on how you define your n. Okay, then after that, C. So determine the value of the length after 7 years. So you can see that your ln here represents the value of the length after n year. So if you want to find after 7 years, which means your n is just 7 up, right? So that's why L7 equal to 250,000. So 1.045, then you substitute 7. Or if you are using the other formula, also no problem. So you try to substitute 7 as well. So 7 minus 1. And from here, you should be able to get the exact same value also, which is 340,215.46. Okay, so this is what you have here for your part C. Okay, so for part D, I want to show you like the calculator, how to work on these two equations for your calculator. Okay, so let's try to look at that. No matter you understand part A to B to C, so you will need to go through this part because these are the part that I forgot to mention in the class. Yeah, and thanks for some of you that, who stay after class and ask me about this, which is how am I going to, key in this in my calculator if let's say I'm using L0 and then R power n. Okay, so that's the thing that we are trying to explore here. Okay, I'm going to show you like 4 different, like now. This one is your anthem rule, and this is your anthem rule as well, right? So if you are able to write the anthem rule, which means you also have the recursive rule for that. So I'm going to show you like recursive for this one, and also the anthem rule itself, and also the recursive rule for this one, and also this anthem rule itself. Okay, so I hope that you get your calculator ready. Okay, so let's try this out. Okay, I'm going to leave my first column here empty because later I'm going to type something. Okay, but we are going to try out for the first one first. Okay, first one, maybe we are going to do recursive rule first. Okay, when you want to do recursive rule, then which means same thing, menu data generate sequence, right? Okay, so our R here is 1.045, which means if I want to get the current term, I need to use 1.045 to multiply the previous term, right? So that's why multiply UN minus 1. So if let's say this question asks for the recursive rule, then this is what am I going to get? Okay, then my initial term is my 250,000. So that's why initial term, it can be representing T0, it can be representing T1, it doesn't matter. But you must make sure that when we are saying A, it is always referring to the first term, okay, which is your T1. Okay, so 250,000. Okay, so now we try to generate this in our calculator. Okay, so now I want you to try to see this is that, because in our calculator, right, our row is go by first row, second row, third row, and fourth row. Because of your initial term is your T0, it doesn't make your calculator first row become 0 here, if you get what I mean. So that's why you need to automatically change in mind that you understand that if let's say this is your T0, then this is going to be your T1, T2, T3, and so on. So which means that when you are reading thing, right, then you need to take the row, then you go and -1. So which means your first row is actually your T0. So you understand that, for example, if your T13, this is actually your T12 if you follow this sequence. Okay, so I hope it, explain how do we do that in calculator. So which means that I don't need to especially change this into T1. But if let's say you find like, minusing 1 and you can't get the idea, then of course you can try to always put your first number, your T1 here. But you will need to do extra thing like calculating your T1 lor. So the idea is you can always type your T0, and after that you just understand it as the first row is your T0, then your second row is your T1, and so on. And I will actually encourage you to try to practice this, like you understand that, which row represent which term, because in finance, we will always use T0 at most of the time. So that's why you doesn't want to like, every time go and calculate T1, and that will take like some extra time. And sometimes if your T1 is not correct, then whole of your equation will get wrong already. Okay, so now we go to the nth term rule. Okay, same thing. Just now we are using this one then, but we type in recursive rule, right? Now we try out the nth term rule. Okay, so the difference between keying in the nth term rule and also recursive rule for T0 R power n is this. Okay, 250,000. Okay, same thing, multiply 1.045 to the power of n. Okay, the thing that you need to be careful of is this. If let's say you choose to put your initial term as your T0, you need to change your N0 to 0, because you need to tell the calculator that the first number that I'm going to generating, or the first number that I'm using here, is actually the 0 term, not the first term. Because or else then some of your number will get wrong. Later I will show you the wrong example. So, but then, okay, you can just follow first. Why we are putting it 0 here? Because 250,000 is our T0. This only apply when you are doing the nth term rule. If you are using recursive rule, then you no need to change that. Okay, it doesn't, it doesn't actually change your answer. Okay, so now I press OK. So now you realize that I get exactly the same thing like what I have previously, which shows that what we are keying in is correct. Okay, now I try to show you, if let's say you didn't change your N0, like what will happen is that your T2, you will get something wrong. So, okay, 250,000, okay, then multiply by just now 1.045, okay, and then power n. Okay, so initial term, I still put 250 and 1,000, right? Okay, but then the T0, I didn't change it to 0 like just now. So I mean, like I accidentally put it as 1. Okay, so you see what will happen is that your second term, right, will actually get wrong. And what happened is that you will have a difference of the number, which is actually not correct, that the sequence will skip your first term due to some mathematical issue like the calculation, like how they substitute here, which I'm not going to discuss here. Okay, so you only need to remember that as long as you are using the formula T0 R power n, you will always change your T0 to, sorry, you will always change your N0 part in your calculator. Okay, you will always change your N0 part of your calculator to 0. If you are using recursive rule, then no need to change. Okay, so that's the idea. So when you are reading it, then which means that, okay, for example, let's try out. Okay, so when you are trying to look at part B, okay, so now you want L4, so you understand that the first term is actually your T0, right? is actually your L0. So if you want to get L4, then which means that you should read it from the fifth term law. Okay, because if let's say this is T0, then this is going to be T1, T2, T3, T4, right? So that's why you can see 298,000, which is the exactly same thing here. So when you want to get L7, which means that you should look at the 8th row in your calculator. So that's why you can see 340 plus. Okay, so we are going to do the same thing here. Oh yeah, just want to show you this. Okay, if you are keen in this, then for this one, no issue lah, because you are using T1, which is the normal way that how you use your calculator. Okay, so but I'm just going to put in here so that you get, you know, the sequence is actually the same. Okay, I'm just going to do this, not doing the recursive rule, because eventually it's the same. Okay, multiply 1.045 power n minus 1. Okay, and the initial term that you have. Okay, if you use this, then your initial term is your 261,250 already lah. Okay, because you are using AR n minus 1 ma, then definitely your initial term referring to the A here. Okay, then after that, okay. Okay, so now you realize that actually you get like exact same thing here, am I right? Okay, so that's why it proves that what you are having here is correct. But the only thing is this is basically your T1, then T2, T3, T4, T5, T6. So you can see that you get a difference here, like this number here is this number here is this number, because of the n here, you remember? Okay, because for this one, we are saying it as T0 ma. This is our T1 ma. So that's why this is T1 lo. So this is our T2, so that's why the T2 lo. This is our T3, so that's why this is T3 lo. Okay, so I hope you get what I mean. So get some time to, you know, understand it. Okay, so now we can try to look at part D now. Okay, so we are finding in which year the price of the land triples in its original value. Okay, so similarly like what we have done previously in question 6 as well. Okay, so that's why 250,000. Okay, when we try to triple it, then we are getting 750,000. So which means we are finding which term giving us a number, you know, greater or equal to 750,000. All right, so same thing by using our calculator. Okay, so I'm going to show you, okay, if let's say this is the wrong one, so let me just delete this. Okay, I don't need this anymore. Can I do it in a faster way? Okay, so now, it's not erased, it's fine. So this is the wrong one, so you don't need to look at that. This one, I'm just doing it for the, you know, for the demonstration, like telling you it's wrong, right? Let me try it one more time. Yeah, it doesn't delete. It's okay. Okay, so which means in this case, let's look at this. Okay, if let's say we generate the first one in our calculator, okay, then we are finding the first one which gets 750,000. Okay, which is going to be here. Okay, between these two numbers. Okay, so you remember just now, so our first row stands for T0. So which means our 25th row actually stands for T24. So our 26th row stands for T25. Okay, so that's why we are writing T24 and then T25. So that's why this part is actually L. Okay, so L24 gives us 719,003.46, and then L25 gives us 751,358.61. Okay, which what you see here. Okay, so similarly, you see, right? If let's say I'm using the sequence that I have just now, so this is the one that more than 750, am I right? But you remember just now, because for this one, we are not changing the term. The first row is basically your T1. The second row is your T2 and so on. This is the normal one that you are not using T0 in your equation. So that's why when you are looking at that, then when you look at 750, okay, you realize that you get the same answer just now as you see, this is your 24th. Okay, this is your 25. So that's why it's exactly the same like what you have here. Okay, then after that, which means our answer here is going to be after 25 years or so. Okay, so if you remember the answer we have for the previous question is at the 26th year. So that's why at the 26th year and also after 25 year, is exactly the same thing, right? So which means if let's say the first year, okay, you started off with 2000, right? So after 1 year is 2001. Okay, then after that, after 2 years is going to be 2002. So which means after 25 years is going to be year 2025. Lor. So you can see that you get exact same answer as what you have previously. Okay, so I hope this clarifies a bit for how to work on the calculator part. So get some time to understand it. Okay, so just a very quick one. So this one is the normal one that you did. So the only one is when you are doing T0, if you are using recursive rule, then the only thing that you need to remember is that because you are generating your sequence starting of T0, so that's why your first row is your T0, then you need to denote the rest of the number by using this relationship. So if let's say you are using T0R power n to generate your sequence, the only thing is you must make sure that you are changing your n0 in your calculator becomes 0, or else then the number will skip like one of it. Okay. All right, so I hope that clarifies. Okay, so take your time to understand it, and also I will post like one more question about this TN thing for your assignment, so you can try to work on it and see you are able to understand the idea or not. If let's say you can do that, then which means you understand, because I try to not explaining it by having like an example with after and at only. Okay, so you try to read the question, then you try to understand what is the and means in the question, then you try to apply it and see. Okay, so thanks for watching. So remember to do your assignment, then I'll see you in next week. All right, thanks everyone. Have a good weekend and happy Easter for those who are celebrating it. All right, so take care.